Hi there. In this video, we're going to talk about the critical z-value that's in the formula for the confidence interval. Before we do any more examples, I want to show you how we get that number. And we're also going to have a different number for each confidence level. Okay, so far we used plus or minus 2 standard errors. That's how we first learned about it. And then in the last video, we actually did plus or minus 1.96 standard errors. Okay, so I'm going to show you where that comes from. The 2 is approximating the 95% confidence level. So we want to be a little more exact in our theory. Okay, so the critical z-value, so what that is, and what I'm talking about is the z star in the formula. It's the z-score that defines the middle area with that percentage. So for example, when we go out 2 standard deviations from the mean, we're capturing approximately the middle 95% of the values within that model. And we're saying that's pretty good. We're cutting off the extremes, right? And we're capturing that middle 95%. And 2 is an approximate value. Okay, so the z-score is a cutoff value, and we've learned about calculating cutoff values. So we're going to use Stapplet, and we're going to use the inverse normal because that is what does the cutoff values. So let's go over to Stapplet. I have the instructions on the notes here for you. Actually, let's just go through what we're going to do, and then we'll do it. So we're going to select calculate a value corresponding to an area. That's at the top here. It's a little screenshot. At the top, there's 2 options under operation. And the first one is an area, which is a probability. We want the second one, which is calculate a value. Okay? And then we're dealing with z, so that means standard normal, right? So that means 0 for the mean and 1 for the standard deviation. Remember, our z-scores are distributed as normal 0, 1. So I'm writing z is distributed as normal, or n, parentheses 0, 1. Okay, so we're going to put all this in here, and then we're going to enter whatever our confidence level is, okay? So let me go over there and do that. And, okay, here's Stapplet. I'm on the Stapplet normal distribution, and if you are on the Stapplet page, the main Stapplet page, you're going to go under probability. The first one is normal distributions. Okay, so under operation, I need to select the second one, calculate a value. A z-score is a value, right? And we put in our 0, 1 for our mean and standard deviation, and plot the distribution. Okay, so this looks, I was going to say this looks normal, right? It looks like how we're expecting our standard normal distribution. 0 in the middle and going by 1s going out. Okay, so we want a boundary value for central because we want the middle 95%. So I'm going to put central for an area of and enter 0.95. And click on calculate values. Okay, and then click show labels on plot. It will show you the z-scores right on there. So it says that our area is 0.95. You'll notice where it usually gives the definition of the model, it actually says standard normal instead of having the normal 0, 1, but that's fine. And you can see that because it's symmetric, it's the z-score on the left is negative 1.96, and the z-score on the right is positive 1.96. So they have the same value but opposite signs. Okay, and that corresponds to the plus or minus in the formula, right? So that's why we only need the positive value, because the plus or minus is already in the formula. That's already taken care of. So we're just going to write down the positive 1. That's where that 1.96 came from. Oops, I got to go back to the notes. That's where that 1.96 came from in the last example we did. Okay, so now I have a table down here just so that we can put in some commonly used excuse me, some commonly used z-values. That way you don't need to look them up every single time. Of course, you can find a new one if you need it, but these are the most common ones: 80, 90, 95, and 99%. Okay, so we just did 95%, which is the third one down. 1.9, oops, I almost wrote 9.5, but it's 1.96 standard errors from the mean. Okay, so let's go back to the top and do 80. Now, what do you predict? Is this going to get narrower or wider? Is it going to be a smaller z-value or a larger z-value? Also, I have the screenshot on the notes here for you as well of the 95% one that we just did. Okay, let's go back to Stapplet and do the 80. So we can keep everything the same, but change our area to 0.80. Okay, so 80, it should come in, right? Because 80 is less than 95, so it should come in towards the middle. And it does, so that gives us a smaller, we only need to go out 1.2816 standard errors to get the middle, to capture the middle 80%. Okay, so that's 1.2816. Notice it just has more values, whereas the 1.96 has just 00 after that. Okay, and then let's go ahead and do the 90. So I'm going to go back to the app and change our central area to 0.90, so that's a little bit wider, 1.6449. Okay, so I wrote that in the notes in the second row of the table. A third row, we had the 1.96. Okay, what's happening? 1.2, 1.6, 1.9, 99 should be wider, right? 0.99 means we're going out even further, 2.5758. Okay, so to capture the middle 99% of the values, we need to go out 2.5758 standard errors or standard deviations, depending on the context. Okay, so those are the most common. Let me go back to the notes. Those are the most commonly used critical z-values. So feel free to use this chart anytime. If you're given a different one, like 92 or 87, then you can use this method to find it yourself, okay? Okay, and now I've got a little part down below here about certainty versus precision. What do you notice about the width of the area as you're calculating the z-values? What does this tell you about the widths of the confidence intervals? Okay, so the width of the area, okay, yeah, so the width of the area is referring to on the normal curve, right? So the width, which corresponds to the width of the confidence interval. So think about it. I like the visual of the curve. We saw that when we had a larger area, we had to go out more standard errors, right? Okay, so the width is called the precision. How precise are we? So narrower is more precise because it's a smaller interval. Wider is less precise. And then the certainty is the confidence level. Okay, so I'll write about that. So as the confidence level increases, I'll go down our chart here. As the confidence level increases, the width of the confidence interval, what does it do? As the confidence level increases, we need to go out more standard errors, so the width of our confidence interval also increases. Okay, so there's a few different ways of thinking about that or explaining that, one analogy we've used before is catching a fish. To be more certain, we need to have a larger net, right? To be more certain of capturing the true proportion, we need to have a larger net. So I'll write something like that. And now we'll use the certainty versus precision. To be more certain of capturing the true proportion in our interval, we need a wider net. We need a wider interval, which is less precise. Okay, so the size of, you can think of it as the level and the width are going in the same direction. The bigger the confidence level, the wider the net, the wider the interval, but that's less precise. So if you think of certainty versus precision, they're actually going in the opposite direction. But if you think, that's because width and precision are going in the opposite direction. Okay, so I like to kind of think about width because then you're thinking in the same direction. But a wider interval is less precise because it could be anywhere in that wider interval. Okay, great. So we will do some examples and I'll see you in the next video.